Today, we're stepping into a moment in science that didn't end with a breakthrough. It ended with silence. Not because the ideas failed, not because the math was wrong, but because the language changed. And when the language changed, the conversation just stopped. Back in 1820, Hans Christian Ørsted was giving a classroom demonstration. He ran a current through a wire, and a nearby compass needle jumped. That twitch wasn't just a curiosity. It shattered the belief that electricity and magnetism were completely separate forces. Ørsted saw the effect, but it was someone else who saw the cause. That someone was André Marie Ampère. He didn't just see a mystery, he saw a blueprint. Ampère imagined matter filled with microscopic whirlpools of current. When aligned, they created magnetism. This wasn't metaphorical, it was a mechanical model of reality. He coined the term electrodynamics to describe how currents interact. And then he proved it. Ampère showed that electricity could act directly on electricity itself. Two wires with electricity running in the same direction, the wires would pull together. With the electricity running the opposite direction, they pushed apart. No magnets, no fields, just motion. He derived a single, elegant formula to describe this force, so clear, so precise, so perfect, that even James Clerk Maxwell himself later wrote, "The whole theory and experiment leaped full-grown and full-armed from the brain of the Newton of electricity." But then the dialect shifted. Faraday and Maxwell introduced the concept of the field, an invisible tension in space, not motion inside of matter. Maxwell admired Ampère deeply, so much that he insisted Ampère's equations must always remain the cardinal formula of electrodynamics. He preserved the math, but he rewrote the meaning. He focused on what the field was doing around matter, not what matter was doing within itself. That shift wasn't a tweak, it was a change of grammar. And once we changed the grammar, we changed the questions we were allowed to ask. Ampère's mechanical intuition, the ability to picture electricity as motion, quietly just slipped away. We kept the equations, but we lost Ampère's intuitive way of explaining them. The conversation didn't fade because it was disproven. In fact, it faded in spite of Ampère's work being set as the cardinal rule of electrodynamics. Even with that foundation in place, the shift still happened. Once the field-based approach took over, the older way of thinking simply stopped getting used. Ideas that didn't fit the new style, or that relied on intuition instead of diagrams, fields, and formulas, just slowly faded out of the discussion. Sometimes they were set aside on purpose, sometimes they were just forgotten. Almost 80 years later, Nikola Tesla saw this loss clearly. He wrote, "The scientists from Franklin to Morse were clear thinkers and did not produce erroneous theories. The scientists of today think deeply instead of clearly. One must be sane to think clearly, but one can think deeply and be quite insane." Today's scientists have substituted mathematics for experiments, and they wander off through equation after equation and eventually build a structure which has no relation to reality. Tesla wasn't attacking math, he was defending the physical intuition behind it. The ability to feel an equation as something happening in the world. And he didn't just talk about that intuition, he built it. His tower at Wardenclyffe wasn't symbolism. It was an actual machine designed to, as he put it, really grab hold of the earth and shake it. When the Army Corps tried to bring it down, it took 3 successive rounds of dynamite to break apart what he'd literally anchored hundreds of feet into the ground. That's how literal Tesla was. His work didn't just challenge the science of his era, it challenged the language that science had shifted into. Not because he was mistaken, but because he was too concrete, too intuitive, too tied to the things that actually worked in the real world. And once you strip out that intuition, you lose the bridge between the math, the symbols, and the reality they're meant to describe. We catch glimpses of this ongoing conversation in the work of Planck, Russell, Young, and Leeds-Skalnin. Each of them grabbed hold of that same underlying structure, maybe without knowing exactly what it was they were handling. But they certainly knew why it mattered, and they proved again and again that they understood how to work with it. They pushed on it, stressed it, pulled it apart, all trying to expose the deeper truths running through matter, energy, and consciousness itself. This conversation, though paused, has never truly ended. And as we move forward, we'll dig into what these thinkers discovered. The findings may surprise you, and they may not be the conversation mainstream science is ready for. But it's a conversation worth having because it touches the fabric of existence and the tension running through all of it. So what did we lose? Well, obviously not the math and not the data. What we lost was the dictionary. This story isn't a history lesson. It's an open invitation for us to pick up the thread. a chance for us to relearn the language, to see what Ampere saw and what Tesla, Planck, and others tried to preserve. Because their conversation wasn't finished, it was just getting started. Then it was paused. And it's waiting for us, for someone who can hear both sides and restart that conversation. This is where our journey begins.